Good day, students. I am Dr. Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. In my lecture series of MSc Final Physics, today I am going to tell you what are the applications and examples of superconductors. As we know that superconductors are the materials which exhibit infinite conductivity. That means they have zero resistivity. Initially, K-ons discovered that superconductivity exhibit in mercury at a temperature of 4 Kelvin. After this discovery, many elements and alloys as well as compounds have been discovered as superconductors. Initially, superconductivity was discovered in low temperature range. As I have told that it was discovered in mercury and temperature was 4 Kelvin. The temperature at which material transform from normal state to superconducting state is termed as critical temperature or transition temperature, and it is denoted as Tc. Now, a large number of elements has been discovered superconductors at low temperatures. Earlier, 27 elements, 27 chemical elements has been discovered to be superconductor, and it was found that all of these 27 elements, they were metals, and they become superconductor in their usual crystallographic form. And this change, that means normal to superconducting change, occur at low temperature and very low atmospheric pressure. And the most common metals which become superconductor were aluminium, tin, lead, mercury. And the less common ones which become superconductor are rhodium, lanthanum. So initially discovery showed that superconductivity exhibited in materials at low temperatures, and earlier only metals were found to be superconductors. The later discoveries shows that there are metals, semiconductors which also become superconductor, and the temperature is low but the pressure is high. Earlier the pressure was also taken to be low. The new discoveries include uranium, cerium, silicon and selenium. These elements exhibit the superconductivity in their usual crystallographic form. But it has been found that bismuth and 5 other elements, these are not superconductors in their usual crystallographic form, but they show superconducting property when they are prepared in a highly disordered form, and they become superconductor and they are stable at extremely low temperatures. So with time many elements are recently discovered to become superconductor. It has been found that superconducting behavior is not shown by magnetic elements. These magnetic elements are iron, cobalt, nickel, manganese, chromium. And up till now, I have discussed only elements which become superconductor. Along with the elements, there are many alloys or compounds which show superconducting phenomena. So, not only elements, but with the combination of elements, that means when we make an alloy or a compound, we can easily form a superconductor. It is not necessary that the constituent elements are individually superconductor. For example, I am taking disilver fluoride, and another example is a compound of carbon and potassium. Disilver fluoride Ag2F. Its constituents elements, that means silver and fluorine, they are not superconductor when they are in the element form. But this disilver fluoride, this is a superconductor. Similarly, C8K, this compound is also a superconductor. That means they exhibit infinite conductivity or zero resistivity. Superconductivity can be also produced in an element or compound if they are doped with some impurity. For example, when we are taking tin telluride, SNTE. Simply SNTE is not a superconductor. But when it is properly doped with impurity, this tin telluride becomes superconductor. That means at a particular temperature Tc, it will show infinite conductivity. So there are many elements which are superconductors at a particular pressure, or we can say at ambient pressure or at a high pressure. Now I am showing you the periodic table which shows how many of the elements are superconductors. Here the red block shows the elements which are superconductors in bulk at ambient temperature, and the green blocks shows the superconductors at high pressure. So we can see easily that aluminium, gallium, cadmium, mercury, these are superconductors in bulk at ambient pressure. Whereas as I have already stated, calcium, selenium, tellurium, these are superconductors at a very high pressure. Now, along with this discovery, lot of researchers are doing work to discover superconductor at room temperature. A lot of superconductors have been found which are categorized as type 1st and type 2nd superconductors. As we have already discussed that type 1st superconductors are those superconductors which follow Misner effect. That means B equal to 0 in this superconductor. Whereas type 2nd superconductors are those superconductors in which up till a particular magnetic field, Misner effect is followed, and after that magnetic field will penetrate inside the superconductor. Superconductors which follow the BCS theory, they are conventional superconductors, and the rest of the superconductors, they are termed as unconventional superconductors. Examples of unconventional superconductors are cuprate based superconductor and iron based superconductor. Apart from low temperature discoveries, high temperature superconductors are continuously being discovered by researchers. So, Now I am moving over to the application of superconductors. Superconductors, they form the basis of energy saving power system, which are superconducting generators. These generators are very small in size and their weight is also very less as compared to the conventional generators using. These superconductors, they are used to form superconducting magnets, and these magnets have been used to levitate trains above the rails. And these trains can be driven at a very high speed and the expenditure of energy is very less. These superconducting magnetic propulsion systems may be used to launch satellites in orbit directly from Earth without the use of rocket. Earlier, to launch a satellite, a rocket was used, but using the superconductor, there is no need to use the rocket. Another application of superconductor is that the superconducting magnets can be used in high efficiency ore separating machines. These high efficiency ore separating machines are used to separate tumor cells from healthy cells by high gradient magnetic separation method. So these superconductors are also used for applicable for human body disease removal along with other applications. Now we know that because they have infinite conductivity, that means zero resistivity, so in a superconductor current can easily flow. So in a superconducting, if we use a superconducting wire, then in this superconducting wire there will be a flow of current without any change in the magnitude. So they are very applicable and they can be used for the transmission line. Another application of superconductor is superconducting sensor. Since we know that superconductor interact with magnetic field, and because of this they can be used to form squid. What is squid? Superconducting quantum interference device. These squid are sensitive magnetometer. What is their use? They are used to detect submarine, and even these squids can detect magnetic field inside our brain. These superconductors have a large number of applications. Now, USA is developing E-bombs. What are these E-bombs? These are devices that make use of strong superconducting derived magnetic field which can create a fast high intensity electromagnetic pulse that can disable an enemy electronic equipment. Another application of these device superconductor is Large Hadron Collider or particle accelerator. Superconductors are used to make extremely powerful electromagnet to accelerate charged particle at a very fast speed, and this speed is near to the speed of light. Superconductors can be used as a memory or storage element in computers. high temperature superconductor power cable have significant high power density capability than copper cables. Hence, these high temperature superconducting power cables they have less weight, less size, and so they are applicable as compared to conventional copper wires which are used. So I hope students you must have learned what I taught you today. Thank you students.